Welcome to The Explainer. Today, we're embarking on a truly grand expedition to decode the brilliant hidden language of the world around us. Just picture it. You're standing right at the edge of this uncharted wilderness, facing a massive terrain of knowledge just waiting to be conquered. Well, consider this your ultimate Grade 6 masterclass in geography. We're going to decode the secrets of the Earth together, transforming all those complex landscapes into crystal clear understanding. By the time we wrap up this journey, you won't just be ready to totally crush your exam, you'll be fully equipped to navigate the entire globe. Let's dive in. So here's our expedition map for today. We'll start with Stage 1, finding north and navigating local maps. Then, Stage 2 covers the absolute rules of mapping. In Stage 3, we're mastering map scales. And finally, Stage 4, navigating the global grid. All right, let's jump right into Stage 1, finding north and local maps. Before we can even think about reading some grand map of the world, we've got to know how to orient ourselves out in the wild. Imagine your compass suddenly breaks or your phone completely loses its GPS signal. No way, right? Well, here's an ancient explorer's secret for finding your bearings using absolutely nothing but the sun and your own body. Seriously. First, just stand outside in an open area, maybe a rugby field. Next, figure out where the sun came up, because that's east. Now, point your right arm straight at it. Then, point your left arm toward where the sun is going to set, the west. Once you've got your arms out like that, the direction directly in front of you is true north. And south? It's right behind you. It's a brilliant, foolproof way to orient yourself literally anywhere on Earth. Now, when we take those real-world directions and translate them onto paper, we get the majestic 8-point compass rose. It's this beautiful, essential little artifact that you'll see on almost every map. It features our 4 primary cardinal points, north, south, east, and west, along with the halfway points in between, like northwest and southeast. And see that north-pointing arrow? That makes sure you're holding the map the right way up, perfectly aligned with the natural world around you. But what happens when we step out of the wild and into the concrete jungle? Cities are just way too massive to fit onto a single sheet of paper, so we turn to street map books. And these books use a totally brilliant system. They use horizontal and vertical lines that divide the whole map up into grid squares. Here's how it works. You look up a street in the alphabetical index at the back, and it gives you a grid reference, something like C4. So you go over to column C, drop down to row 4, and right there, right at exact intersection, boom, you've hunted down your exact location. Sometimes, though, you really don't need a highly detailed map, and that's where a sketch map comes in. Say you need a quick escape route, or you just want to show a friend how to get from your school to the local park. You draw a sketch map. It's exactly what it sounds like, a rapid, simplified drawing based on what you observe. It relies heavily on bold symbols and familiar landmarks, rather than, super precise measurements. It's quick, it's incredibly effective, and honestly, it's a crucial tool to have in any explorer's backpack. Okay, moving on to Stage 2, the rules of mapping. Now that we've found our bearings locally, it's time to learn the universal language that all cartographers, that's mapmakers, actually speak. Because a map isn't just a pretty picture, it's a whole informational toolkit, governed by 10 universal conventions. Think of these as the laws of the land. A map absolutely must have a title telling you what it is, a compass rose or north arrow showing direction, a key or legend, a scale for measuring distance, symbols for landmarks, a grid system, borders, clear labels, exact latitude and longitude coordinates, and standard color conventions. You'll definitely want to memorize these 10 laws because they are the unbreakable rules of our mapping universe. Let's zoom in on one of those laws real quick. The map key, or legend. Maps simply don't have the space to hold full sentences describing every single building or feature, right? So they use simple, elegant little icons instead. A cross becomes a hospital. A tiny little tent, that's a campsite. A miniature airplane is an airport. The key is what translates these tiny symbols back into real-world features, letting you read the landscape like an open book. And, just like symbols, colors on a map have a universal meaning too. The map's color palette perfectly reflects the vibrant hues of our actual Earth. So when you see blue, you're instantly warned of watery depths. We're talking rivers, oceans, and dams. Green guides you toward lush vegetation like parks and forests. Brown tells you to gear up for a steep climb because that indicates mountains or high elevation. And yellow or gray, well, that indicates you're approaching the concrete and roads of urban, built-up areas. Which brings us to Stage 3, mastering map scales. Scale is this vital mathematical tool that allows us to shrink massive sprawling landscapes all the way down to a single piece of paper you can literally hold in your hand. But hey, pay super close attention here, because this right here is a classic trap for so many young explorers taking their exams. It sounds completely backwards at first. A large scale map, like 1 to 10,000, actually shows a very small geographical area, but with incredibly high detail. Think of your local street map, where you can see individual buildings. On the flip side, a small-scale map, like 1 to 500,000, shows a massive, large area like an entire country, but with very low detail. So remember, large scale means large detail for a small area. Do not let that trick you on test day. So there are three main ways mapmakers show scale to help us estimate real-world travel time. First up is the linear or bar scale, which is an actual physical line you can measure against right on the paper. Second is the verbal or word scale, which is just written out in normal sentences. But perhaps the absolute most crucial one is the third type, the representative fraction. This one is written as a ratio, like 1 to 50,000. And what that simply means is that 1 single centimeter measured on the map represents 50,000 centimeters out there on the real dirt of the ground. And that brings us to the golden, absolutely unbreakable rule of representation. You need to lock this into your memory. We never say 1 centimeter equals 50,000 centimeters. No way. We always say it represents. Why? Well, because 1 tiny centimeter of paper literally cannot physically be 1,000 meters of dirt. That'd be magic. It is merely a representation. If you master this phrasing, I guarantee you'll impress any geography examiner. So how do we actually use this to survive out in the wild? Well, let's try calculating the flight path of a bird, a direct, straight-line distance. First, you just lay your ruler on the map and measure the distance in centimeters. Let's just say it's 4 centimeters. Second, you multiply that by your scale factor. So if the scale is 1 to 50,000, you multiply 4 by 50,000, which gives you 200,000 centimeters. Finally, you convert that huge number into a measurement you can actually use. 200,000 centimeters is 2,000 meters, which is exactly 2 kilometers. Boom, you've got your distance. Now, that works perfectly for a bird flying in a straight line, but what about us humans on the ground? How do we measure the distance of a winding river, or maybe a beautifully unpredictable, curving mountain road that twists and turns all over the place? I mean, you can't exactly bend a plastic ruler, right? Well, the solution is a truly ingenious, tactile little survival trick. To measure indirect distance, all you need to do is grab a piece of string or wire. You carefully lay that string down precisely along the twisting curves of the route right on the map. Pinch the string exactly where your journey ends. Then, simply pull that string perfectly straight and lay it against the linear bar scale printed at the bottom of the map. And just like that, you've measured the exact distance of a totally winding road. How cool is that? All right, we've made it to our final stage. Stage 4, navigating the global grid. For this last leg of our journey, we're going to cinematically zoom all the way out. Imagine we're rocketing into outer space to look back down at our majestic rotating Earth just to understand its invisible global grid system. We are talking about the two monumental grid forces of our planet, latitude and longitude. Latitude lines, also called parallels, are the horizontal lines running east to west. They basically measure how far north or south you are from the equator. And here's the key: they never, ever touch each other. Longitude lines, on the other hand, are called meridians. These are the vertical lines running from north to south, measuring east or west from the prime meridian. And unlike latitude, longitude lines all converge and intersect directly at the north and south poles. When we bring both of those forces together, we get this grand global grid. You can clearly see the 0-degree equator slicing the Earth in half horizontally right there in the middle. And then there's the prime meridian, also known as the Greenwich meridian, stretching vertically from pole to pole. By crossing these horizontal and vertical lines, we get exact coordinates. It's essentially a precise global address for every single square inch of planet Earth. So why does all this actually matter to us? Well, think about it. Every single day, massive geographical stories unfold in the news. An earthquake shakes a distant city, floods alter a whole landscape, or maybe athletes from all over gather in a global metropolis for the Olympic Games. By mastering latitude, longitude, map reading, and scale, you are unlocking the ability to immediately pinpoint exactly where these world-changing events are happening. You're connecting the news to the actual globe. So, fellow explorers, you now have the tools in your backpack. You know how to find north without a compass, you can read map symbols, you've conquered the tricky math of scale, and you can navigate the global grid. My final question to you is this. When the next major global event strikes, will you be ready to map its exact location on our magnificent world? I'm absolutely sure you will be. Best of luck conquering your geography exam terrain, and hey, keep exploring.